Okay, so here's a parametric differentiation question. We've got a parametric equation, x is 4 sine theta, y is 2 cos theta, and theta is between 0 and 2 pi. So first thing, make sure our calculators are set in radians. Let's have a go at A. A says find dy by dx. Well, dx by d theta is 4 cos theta. Dy by d theta is minus 2 sine theta. So that means that dy by dx is equal to dy d theta over dx d theta. So that gives me minus 2 sine theta over 4 cos theta, which is the same thing as minus a half tan theta. Okay, so that's A taken care of. Now B, the tangents to the curve at the points A and B pass through point 32. Right, okay, so now we found the derivative. Derivative is a half tan theta. So that is the equation of our tangent. Okay, so what we're going to do is we're going to work out the equation of the tangent by using the normal equation for a line, y minus y1 equals m times x minus x1. Okay, right, so that's y minus, well, y1 is just the y that we're given, which is 2 cos theta. Our tangent is minus a half tan theta. And then we have x minus our x, which is 4 sine theta. Okay, so this is our tangent equation. Okay, so now what we're going to do is we need to turn this into 4 cos theta plus 3 sine theta equals 4 at A and B. Okay, well, first thing, let's rearrange this. So I've got y minus 2 cos theta. What I'm going to do, I'm going to multiply by 2 cos theta. And I'm going to do that because in this I've got, at the moment, I've got cos, tan and sine, and there's no way I'm going to be able to get that into what I want. So if I do that, I've now got 2y cos theta minus 4 cos squared theta is equal to minus sine theta, and that's multiplying x minus 4 sine theta. Okay, so I've got 2y cos theta minus 4 cos squared theta. Let's multiply the brackets. So I've got 4 sine squared theta minus x sine theta. Okay, so now I'm going to rearrange this again because I've got a sine squared and I've got a cos squared. And we know our favourite identity, we can do something with those. So I've got 2y cos theta, and I'm going to add my x sine theta, and that is equal to 4 sine squared theta plus 4 cos squared theta. And this is where I can use my favourite identity, that my sine squared plus my cos squared equals 1. So nothing changed on the left hand side, but the right hand side is now just equal to 4. Now we're told that this passes through a point 3, 2. So I can substitute in the fact that x is 3 and y is 2. So now I've got 2y, which is 4, cos theta plus x, which is 3 sine theta, and that is equal to 4. And that was what I was looking to show. So that's part B taken care of. Now we're going to find the values of theta at A and B. So for part C, trying to find theta. Okay, so now I'm going to use R sine theta plus alpha, because remember I've got two functions and I've got two different coefficients. Okay, so then this is going to be the same. I'm going to basically write the equivalent in this form of R cos 4 cos theta plus 3 sine theta. So remember, go through the expansion. The expansion for R sine theta plus alpha is R sine theta cos alpha plus R sine alpha cos theta. So I'm going to find R sine alpha. So what to do, I look at my sine alpha. Okay, and my R sine alpha multiplying cos theta, and I look at my original, and that's 4, so my R sine alpha is 4. Now I want R cos theta. Again, I look at my original, my R cos alpha is multiplying sine theta, which is a coefficient of 3, so that's 3. Okay, so now I know that tan of alpha is sine of alpha over cos of alpha, which is 4 over 3. So then that means that alpha is equal to arc tan 4/3, which equals 0.927295, rounded. Okay, so now I've got alpha. Now I need r. Well, r squared is equal to 4 squared plus 3 squared. Remember, it's like Pythagoras, which means 25. So r is equal to 5. So now we can write it as 5 sine theta plus 0.927295 is the same thing as 4 cos theta plus 3 sine theta. Right, so now we can try and solve this because we want to find values for A and B. So theta plus 0.927295 is equal to 4. Remember, that's what we were given before. Okay, so now we've got that. We need to find out what theta is. So this means that theta plus 0.927295 is equal to arc sine of 4/5. Okay, and actually that means that theta plus 0.927295 is actually equal to 0.927295. Okay, remember, this is the sine curve. So our sine curve looks like this: 2 theta, 0 theta. So if we have a solution here, we also have a solution here. So what's this one? This one is pi minus the angle, if that's our angle. So we need to have a second solution, which is 2 pi minus 0.927295, which gives us 2.214297. Now finally, theta is equal to our answer minus 0.927295, so we get that theta is equal to 0, or theta is equal to 1.287, which is roughly 1.29 to 3 sig figs. Okay, so that's it. That's part C taken care of.